Hello, and welcome to another episode of Max's Money Podcast. Today we have the toaster himself, Yeon.
Well, hello. Um, it's really like an honor to be in this kind of podcast.
No, it's not. Let's be honest.
Yeah, I'm actually not being honest. I'm sorry. I'll try to be honest.
I'm gonna no. You need to realize there's a thing called white lies, where you can technically lie just to appease everyone, but in reality, it's actually a lie. So it's
Well-
better to be lying sometimes than being truthful.
Well, that's actually kind of true, but what is white lies in the first place? Like, how would you define what is white lies?
First of all, a white lie is a
Okay,
lie
both of-
that is intentionally meant to, a lie that's said to undermine a truth in an exchange for something else, like in this case, appeasing someone else.
Mm-hmm. Well, that makes sense. So what is the thing that we're going to talk about today?
I love physics. You love physics.
Yeah.
What else can we talk about?
Physics.
I'm gonna cut in here. I'm the editor, Christian. We're not talking about physics again after what happened last time.
I don't care.
Same difference.
Oh yeah, it is.
Same difference.
It's not the same.
Same difference. You're not even supposed to be in this episode. Shut it.
Anyway, well, what about physics, actually?
Well, we could talk about the history, I guess.
History of physics.
Yeah. Everything before Newton can be considered to be non-classical.
Yeah,
And then,
there were a lot of like misconceptions about how things work out. Like,
you know
before
how the sun used to be considered an orbiting star, and the Earth used to be the center of the world.
right?
That's one example.
Yeah, and also how the heavier objects tend to fall faster to the ground when they're only at the same height at the same time.
It's not false because there's this thing called air resistance.
I mean that is what people were thinking, and
Yeah.
maybe some people might have tested out with feathers and papers along with the stone, and maybe they have concluded that the stone falls faster. However, you should remember, now we know that this is because of air resistance, and that feathers and papers fall less due to their winds interrupting in their motion.
Exactly. So physics of history can really be represented by one thing: constantly trying out new theories, and whether or not it works or not, replacing all previously held facts. Like in this case, heavier objects falling faster.
Yeah, you should always question your knowledge, and you should always try to test out, try to debunk the theory you currently hold. And that's kind of the same with all the sciences.
So are you saying that I should be a very skeptical kleptomaniac that questions every single thing that I hear? Like, 1 plus 1 equals 2? Maybe this is false. Let's try different things. I think there's a limit to how skeptical you can be, though, in some ways.
I mean, well, it is true, but I think it's really good for you to be skeptical in all times, because even, for example, let's go back to the example of how heavier objects fall faster. Well, when people were having those kind of knowledge, they would never would have questioned that, right?
Yeah.
They would always think that that is a definite truth. However, we know that it's not. So basically, you should always try to question that. Even like maybe 1 plus 1 is 2, and you might also question that as well.
Well, the reason why 1 plus 1 equals 2 is because of a central axiom that we have defined that sets 1 plus 1 to be equal to 2. So there's actually these 27 axioms in mathematics that defines every single possible theorem of mathematics, and what this means is that theoretically you can alter truths, and once you do that, things 1 plus 1 equals 2 no longer becomes true.
Actually, like I'm not really sure, but there was this thing in mathematics. There was one theory or like one part or one like aspect of mathematics that perceives how 1 plus 1 equals 2 is not actually accurate. Like it's like between 1.99 and 2.01. I think I've seen it like on the internet. I'm not really sure how this works. Yeah, my memory starts fading away, but yeah, there was this kind of thing that even 1 plus 1 equals 2, which is like a really simple idea, could be debunked when you see it in some other perspectives.
For instance, floating point errors. Like when you try to represent bits as something that's other than like if you try to represent decimal points as 1/2 and 1/4 and 1/8, what happens is that you only have a certain amount of bits you can store for something, and as a result, you get these 1 plus 1 equals like 2.0001. But it's only for multiplication or division, though. So,
Yep.
That's just one example, I guess.
Mm-hmm. What kind?
Or in the previous episode, the one on time,
Yeah.
adding up 8 p.m. plus 8 o'clock plus 8 o'clock is 16. It's not 16, but it's 4 p.m.
Well, I mean, that one is a little bit different, right? Because
Yeah, they're all a little different in their own rights.
yeah, because that one is like that's like a promise that we made. Like, when you're dealing with time, it's up to one 1 to 12, and then it goes back into 1, but this time with AM to PM or PM to AM.
So this really defines on how you set the boundaries of the question to be at. So if
Right.
you set the boundary to be a time, then this is what happens. But if you set the boundary to be a computer, then that's what happens, and
Right.
so on and so forth.
Are there any physics news that you're pretty interested in right now?
Copenhagen interpretation for one.
Well, could you try to say that for the people who are listening to this podcast, what it is about?
So basically, the Copenhagen interpretation is the idea that every single particle in a human body is simultaneously a particle and a wave, instead of a point particle. This basically is a deviation from classical mechanics, because classical mechanics assumes that every single object is as it is.
Mm-hmm.
But the Copenhagen interpretation says that this could be wrong, and instead, what happens is that these point particles add an effect of RNG to mechanics. Like previously in Newtonian mechanics, what happens is that if you knew everything about a system, you can predict what's going to happen. You can predict how the universe is going to end if you're given every single point particles on these universes,
Yep.
matter, velocity, so on and so forth.
Yeah.
But then Copenhagen interpretation adds this RNG aspect that completely revolutionized how we viewed physics. For one.
Interesting. That's like a really interesting concept. I think people who are listening to this podcast who are interested in those kind of fields should really search that up and learn more about it, right?
It's kind of outdated though, because it's now.
Well, I mean, although even if it is outdated, I think it's a really interesting aspect. It's really interesting perspective to see,
because it's like you're basically there's this set rules, and this interpretation says screw these rules. There's this new set of rules that I think everything runs on.
Right.
And after extensive theory test verifying, it works. But how do you get to here in the first place?
I mean, for theories to be like those kind of are really theoretical, and it's not really easy to test it out, right?
Yeah.
For those kind of things, it's really hard to actually make a certain statement into what's going to happen. It's basically more likely to be a interpretation, and maybe it's a assumption that we made from our mathematical knowledge. I think in my theory of knowledge class, we also kind of dealt with these kind of theoretical physics branches and how whether these are considered as a true science or not. Some say that since theoretical physics only depends on the mathematical assumptions and the calculations we have beyond the physical evidence we have over there, so that therefore it does not define as science, because for science what they say is that there needs to be an experiment, and there should be experiment that argues or counters the original theory or original knowledge system we have. So what do you think about that?
So
do you think theoretical physics is considered as science or not?
I mean, how do you define science? Let's start with that.
I mean, yeah. So, well, what I think about science is really pretty abstract and really vague, but it is how we gain knowledge of the world that we're living in, how the world functions, how naturally, how these kind of.
Then I would argue that applied physics is not a science, but theoretical physics is a science, because applied physics you're just applying theorems, these pre-held theorems into a different set of a world, while theoretical physics is actually you're implementing these theorems that operate on this world that we live in.
And what is the difference between theoretical physics and pseudosciences?
Computer science?
Pseudosciences,
Pseudoscience?
Well, for example, let's say there's this arbitrary claim that the world or every object on Earth expands twice of its size than it was yesterday.
Well,
How can you prove that? I mean, there's no way for you to prove that. However, there's no way for you
There's
to
actually a way to
disprove
prove that.
I mean, there's no way to
There's this
disprove that.
there's this thing called redshift.
No, for example, what if all the particles, the particles, not the particles are separated from each other, all the particles, even all the tiny quarks and everything are expanding twice of its size. It's not about redshifting. It's basically everything on the universe is expanding its size. It's slowly, so that
there will be
in
no
a
way to
day
prove.
it's going to be twice of its size. However, there's no way to prove it, but there's no way to disprove it as well. So then, can we consider this as a science?
A science is basically when you have a bunch of theorems and you prove them through excessive testing. In cases like this, the statement you just said that the idea that particles double in size, it cannot be tested. So
Right.
it could be a theory at best, but without any extensive evidence, it can't be incorporated into like an actual
Like,
science.
Then what
makes
about theoretical physics then? Like
Theoretical physics is claims that can be tested. Like
how? How could it be tested?
let's go back to the
What about, for example, what about string theories, or what about the existence of
string theory actually was proved when they measured the. I think I'm not so sure about this, but I think it was like they basically measured like the distances in particles and saw that the symmetries within the particle formations had actually I don't know about that. I don't know topic that at all. I don't know topic at all. I'm just a high schooler.
Yeah.
But
So
I think, but it was proven to be true by some scientists.
yeah, I mean, for me, like I'm not the one who kind of goes against the theoretical physics. I'm like a huge fan of it. It's just that I just wanted to say that there are some people who
Come with their own
are
science.
questioning about the validity of some of the theories that are held within the theoretical physics branch.
I mean, questioning it is good, but there should be some basis for the questioning. Does that make sense? You can't just be like, oh, this world is expanding at 6 times the size for like no arbitrary reason.
yeah, I mean, they are questioning like those kind of approaches.
Like flat Earth theory.
Yeah, yeah.
Yeah, so basically physics is just a bunch of theories that pass through this timeline. People questioning those theories and people testing
And we're
it,
building
testing
up.
it, and
We're
that's
building up. We're breaking some parts down if it is not accurate or if it is not built correctly.
And yeah, and now here we are with a superstring theory, which will probably be broken again sometime in the
I
future.
mean,
by
all
some
of our
theory.
conventional, like this physics are already kind of established. Now it's like we're going to see like dealing with those contemporary physics.
Well, here's a problem. Up until the Copenhagen interpretation, people thought that physics was a complete subject and there wasn't anything else to discover. That's what we thought until this came along.
I think we never thought that physics was like the subject that we are completely done with having new discoveries, because I mean after after 1800s, basically all of like that Newtonian physics and like all those kind of like normal, I shouldn't say normal, but like the physics we have in our real life situation, that were mostly should I say discovered and were utilized as like equations and complete theorems. It's just that now like we should go is going really macro.
So you're saying
Really
that
micro.
it's a very exciting future we have for physics,
Yeah, I
and
think
with a bunch
we're
of
gonna-
weird
yeah,
theories.
we will have like really exciting discoveries for the things we cannot see or things we cannot even imagine, should I say.
That makes sense. Well, thank you for your thoughts.
Well, I mean, it's just like what the high schoolers thought.
Just some high schoolers, some physicists in the real world right now who's probably watching this will be like, these two suckers don't even know what physics is.
Oh, I mean, yeah, of course, like our knowledge of physics is too shallow for us to even discuss about this topic.
Which is a disclaimer, by the way.
Yeah, I mean, but it was pretty fun. Like,
Yeah.
and
It's
by-
just ideating.
yeah. Well, I guess that's the end of the
Any,
podcast for today.
any last comments?
Last comment about what? About this topic or about like me? Like,
Anything you want to say?
I mean, well, I think it was a really fun opportunity for me to discuss physics. In fact, like, I was invited like 2 minutes ago to
That's a corporate secret. Don't say it.
2 minutes ago before this video started for
That's
me
a
to
corporate secret.
start recording this thing. So there were no script for me to have. Everything just came out.
It's a podcast. You're not supposed to have a script. What breaks the point if you're supposed to like just read off of a
but
script?
I was really should I
You still
say?
did a pretty good job at it. Good job.
I mean, like you just like kind of say, oh, do you want to be in the podcast? And I was like, okay, when? And she said, you said right now, and I was like, okay, that is not expected, but I'm still gonna try, and I think it worked better than I thought. It was
Okay.
really fun. It was
Okay.
really exciting. Oh, thank you.
Well, thank you for tuning into another episode of Max's Blonde podcast. We will see you next week.
Bye.
Bye bye.
Please.